Hello students, you're watching the second video of the topic relations and functions, and in this video we're going to discuss about functions and their domain and range. Specifically, we'll talk about function as a relation and the well-definedness of function. We'll also see some examples of a function, and we will also see what is domain and range and codomain, and we will also find out how to find out domain of a function. So let's start by taking a relation which contains the ordered pair x comma y, and x, y both are real numbers, such that it has a rule that must be followed: y is equal to x square. That means the second element, the output, should be square of the first element. Think it as a machine, okay? Whatever it gives into that machine, it squares that and returns that to you, okay? So its process, its function is squaring a number. So think it as a machine, and you give 1 as an input in this machine. What will be your output? It should be squaring 1 and will return you 1 as its output. Now let's say if 2 is your input, then what should be your output? Your output is going to be 2 squared, that is 4. Anything that you give here, it will square it and return you back. So we can understand that 1 is in the input, that will give you a 1 as output. Similarly, if minus 1 is in the input, that will also give you 1 as output, because we know minus 1 square is also 1. So there are 2 elements in the input that connects to a element in the set of all outputs. Okay. Similarly, 2 is going to 4, minus 2 is going to 4 as well. 3 is going to 9, minus 3 is going to 9 as well. 4 is going to 16, minus 4 will also go to 16. Okay, so that was one of the relation. I'm coming to functions later, okay? Should we call this a function? I'm coming to that later. Now we'll check out another example of a relation. The relation looks similar, but we have changed a little bit. It contains the ordered pair x comma y, where x is in a set called A, whereas as you can see, A is the set of all perfect squares. Okay, it contains 1, 4, 9, 16, 25, and it contains more elements like 36, 49, and so on. Okay, it contains more elements set. And y is basically an integer. Y belongs to z means y is an integer. Okay, what are integers? Integers are the numbers like the whole numbers 0, 1, 2, 3. You also have the negative numbers as well. Okay, minus 1, minus 2, minus 3, and so on. Okay, so try to understand, if 1 is your input in this function, what is going to be the output? What are we asking actually? Think that which number's square is 1? We know that y square is equal to 1. So we are asking the question, which number squared gives you 1 as the answer? We know that plus 1 gives 1 as the answer, because plus 1 square is 1. Also, minus 1 square is 1. So here 1 is connected to two numbers, that is plus 1 and minus 1. 1 is connected to both of them. Okay. Similarly, can you now tell me that what is the output for 4? Just you can pause the video and think about it. How many outputs will be for 4 and what will be the outputs? So the output is going to be, similarly, we are asking that question, that whose square is 4? We will get two answers. 2 square is 4, minus 2 square is also 4. See, 2 and minus 2 are the values of y, so that is the output. At 4 is the input. So for 4 input, you are going to get 2 and minus 2 as the output. Very good. So we write that here, plus 2 and minus 2 are going to be the outputs for 4. Similarly, 9 will give us the output of plus and minus 3, and so on. So now we will differentiate between the previous relation we have seen and this relation we have seen. In the previous relation, if I just go back, in the previous relation, every input, for example 1, it has a single output. 1 gives you a single output, that is 1 only. 2 gives you a single output, that is 4 only. 3 gives you a single output, that is 9 only. Similarly, -1 gives you an output, that is 1 only, right? Maybe multiple elements giving you same input, that is correct, but one input gives you only unique output, okay? That is the main criteria for a relation to be a function, okay? Whenever a particular input gives you a unique output, then we call the function is well defined. That is the definition of well definedness, okay? Whenever a function is giving you a unique output, then only we call the function is well defined, okay? So this one is a function, it was the relation, it qualifies to be a function, but next one where we were getting like for a single input 1, we are getting multiple outputs, that is +1 and -1. This does not qualify to be a function. So if you keep that diagram in your head, whenever you see a function, try to represent it with these arrow diagrams, we call them arrow diagrams. And if you think that what kind of relation we are getting is from one point multiple arrows coming out, then it's not a function. From one point only one arrow coming out, where they are going we don't have to see, okay? So if from one point one arrow is coming out, it is a function. That is one of the criteria. Now let's consider another example and try to understand what is the next criteria for a relation to be a function. So the next function we are considering is y is equal to 1 by x. Where this is wrong, sorry. This should be x can be any real number and y can also be any real number, okay? Wait. So let us take different values for x and see what are the outputs we are getting. Fine. So let's say we take maybe 1 as input. What is going to be the output? We see what is the process of that function. The function takes any number and returns you the reciprocal of that number. It does 1 by of that thing, right? Whatever you give, it does 1 by of that thing. So 1 should become 1 by 1, that is 1 after. Similarly, 2 should become 1 by 2. 2 should become 1 by 2. And that is also a real number. So from real numbers, we are taking the input and we are getting the outputs in real numbers only. 3 gives you 1 by 3. You can work with any other number, like maybe a irrational number you can take. √2 would become 1 by 2. Similarly, maybe pi, which is an irrational number, will become 1 pi pi. No matter. Everything works. Really? Does everything work? Maybe the negative numbers does not work. Let's see. Let's see with an example. Let's say -5. Its output is going to be -1 by 5. Because that's because what is the reciprocal of -5? It's 1 by -5, which you can write as -1 by 5. Yeah, so negative numbers also works, okay? What about 0? Does 0 work? 0 becomes 1 by 0. And we know that in real numbers, division by 0 is not allowed. Division by 0 is not allowed. It's not allowed. Okay? So this is not a real number. This is not a real number. So 0 does not have any output in it. Okay? That is another red flag. You cannot take it. You cannot take a function where a particular input does not have an output. You cannot take a relation where a particular input does not have an output. Then it does not qualify to be a function. I hope you understood. So two things to look for. One element is giving you multiple outputs. That's one of the no condition. Okay. And element which does not give you anything, that is another rejection. Okay. So whenever you see these two things in a relation, you call that it is not a function. If you don't see these two, it is a function. Now there is a very important notion that we use in functions, that is we write function in y equal to fx notation. So what is that? See, till now I was calling the inputs and outputs. In mathematics, in this topic of functions, we have a really good name for these inputs and outputs. Whatever is your input, they are all of them are called pre-images. They are known as pre-images. And the output, they are known as images. They are known as image. Okay. So whenever you give x as input in any function, you should get a unique output. You must get a unique output. It should not be like that x does not have any output, then it's not a function. It should have only one output as well. Then let us consider that output is y. Okay, how does it become y? By going through, x is going through the machine called f. F is the name of the function. It is the name. Okay, whatever name we can assign it. Okay, it can be any letter. We can assign the function of name of function as any letter. Usually we take as f. So f is the name of the machine, and this is where you give input. Okay, f has a bracket. After that, you give input here. You write x, and that f, after f processes x inside, and it makes it y. So y is equal to fx. Any function is written like this. Okay, I hope this part is clear to you, all of you. Okay, so here this x is known as the pre-image. From now on, I will not be calling them inputs, rather I will be calling them as pre-image, and whereas y is called the image. Y is known as the image, or fx. Y and fx are same thing, that is known as the image as well. Okay, so let's try to understand that same thing by an example. For example, let's say you have a function fx is equal to maybe 2x plus 3, where f is a function from real number to real number. What does it mean? Real number is the set of all pre-images, that means inputs, and this real number is the set of all images, that means the output. Okay, we call this real number is a domain, and we call this set, the second set where the images are going, the codomain or range. There is a certain difference between codomain and range. I'll discuss that in a minute. That is the last segment of our video. Okay, so here the name of the function was f. Whenever you give input of x, whatever you give input of, it returns you what? It returns you whatever number you have given, twice of that plus 3. It returns you twice of that plus 3. For example, if you give input of 1, it will first multiply this. First step is to multiply with 2, then to add whatever that result was, it will add 3 with it and returns you the value. So 1 becomes 5. I hope you understood that. Okay, going into the next segment of our video, that is understanding domain and range. As I have just said, the set of all inputs is known as the domain. You must understand that domain should not contain any element which does not give you an image, because in that case, it will not be considered as a function. Okay. Set of all outputs is known as the range of the function or codomain of the function. Now, what is the difference? Let us understand by an example. Okay. Let's say I said that a function is basically a machine. Let's say you have a juicer machine. Okay, juicer. Okay. What is the input that you give here? A fruit. Okay. And what do you get as output? Juice. Definitely. You can give input of different fruits, you will get output of different juices. So set of all kinds of fruits is your domain and set of all kind of juices is your range. Okay. Now try to understand. In your machine, the juicer machine, I'm just denoting with J. Maybe you have one of the juicer at your home where you can make juice of, let's say, oranges. You can make juices of apples. Maybe you can make juices of grapes. Only these three things. So what is your domain? Your domain is a set containing only these three fruits. And what will be your output? Three kinds of juices, right? Three kinds of juices. But let's say you go to a restaurant where they have a big machine where they can get juice of any kind of fruit. Maybe they can do pineapple juice, they can do the sugarcane juice, anything. So their domain is all of those fruits, correct? Their domain is all of those fruits. It's a bigger set. And their range, their outputs are all of the juices. So if you consider all kinds of juice in a set, all kinds of juice in a set, that is called a codomain. So codomain is basically a bigger set of that same category. Whatever the outputs you are getting, they were all of same category. All are juices, right? You are getting only three types of juices. So that was your range. Okay, how much your machine can perform. That is your range. Okay. But what is the category? The category is it can have all kind of juices. So that bigger set is known as the codomain. And a part of that can be considered as the range of the function. I hope that is clear. I'll give you one more example to make you understand. Let's say we have seen the first relation, you remember? The first relation we have seen, you remember? Y is equal to x squared, which we already proved to be a function because every number was giving a unique output. Every input, every pre-image was giving an unique output. Okay. So here, what is the domain of this thing? Domain is what is the value of x you can take. You can, what number you can square? You can square any real number, right? So its domain is going to be all real number. But if you try to carefully think about it, what is the value of y? Whatever you square, maybe you square 0, you are going to get 0. You square any positive number, they are going to be some sort of positive numbers only. But if you square any negative number, then that is also a positive number. Square of any negative is always a positive number that we learned. Okay. So its domain is real number, but its range is only positive real numbers, or rather I should say negative real numbers. Non-negative real numbers. Positive and 0. Okay. So this is the set which denotes the non-negative real numbers. That is the range, which they are numbers basically. They are all real numbers. What is special here? They are non-negative. So that set is contained in another set which is real number itself. So if we define, let's say the name of the function is f, we can say the function is a function from R to R only. Because we know, I don't want to know that specifically what are the outputs, but I know the outputs will be some sort of real number, okay? So that we simply denote it with from R to R. So that R is the code over. But do we get all of them as the output? No, we get only positive real numbers as the output. So positive real number is our range. That is the difference between domain and codomain and range. Okay, I hope that is fine. Now we'll jump on to the next segment of our video where we try to find out domain of different real functions. So finding domain of a real function, I have started with an example. So I said domain should be such a set where all the elements should have a image. Now, first thing we need to understand what is a real function. A function is real means its output is going to be real number, may not be all real input, input is going to be real number, may not be all real number, but like it should be nothing else than real number. Okay, may not be all of them, maybe some of them will be excluded, but whatever there are, they are a part of real number, definitely. Okay, and its output is going to be real number also, may not be all of them, some of them. Okay, so how do we know which numbers to be excluded from the domain, which numbers will not work? For that we have some techniques. First of all, we need to focus that where the function is becoming undefined. Now there are some cases when a function becomes undefined. For example, when you have a function written in the form of like a fraction, something like this is written, maybe a by b. A is a expression, algebraic expression, b is a algebraic expression. If that b becomes 0, that means the denominator becomes 0, then at those points, for whatever values of x, the denominator is becoming 0, at those points the function becomes undefined. We need to avoid them because for those points there will be no image coming out. Okay. Similarly, if there is square root and inside that if we get negative, we need to avoid that as well. Okay. If there is negative inside a square root, we need to avoid that as well. So mainly these two things are to look for. Now there are some other cases also when we'll be doing logarithm. If you have logarithm, inside that everything should be positive because logarithm does not accept negative values. Okay. Mainly it should be not 0 as well. Okay. So that we will discuss later. For now, mainly two techniques to remember, that denominator should not be 0 and inside square root there should not be any negative 2. So if we remember these two and focus on this function now, we see there is a square root. So the expression inside square root should be greater equal to 0. It should not be negative, so it can be greater or equal to 0. So x square minus 16 is greater equal to 0. What does that give you? X square is greater equal to 16, or we may say that x square is greater equal to 4 square. Now remember one thing, whenever you see this type of inequality, x squared is greater equal to a square, in the number line, if you denote minus a and a as 2 points, if you have greater than sign here, then it will denote the region outside the interval minus a and a. Whether minus a and a are included, that will be depending on the equal to sign here. If equal to sign is here, then minus a and a is going to be included. If equal to sign is not here, then minus a and a will not be included. For example, if you have x square greater equal to a square, then x will belong to everything starting from minus infinity to minus a closed interval, because minus a is included, equal to sign is there, union a to infinity. I hope you understood this. But if the greater than sign was not there, if it was just like that, x square greater than a square, then x belongs to minus infinity to minus a union a to infinity. That is the condition. Okay. Fine. Now, applying that condition here, we get x belongs to minus infinity to minus 4 closed interval, because equal to sign is there, union 4 to infinity, and that is our domain for this function. I can verify by taking some values. Let's say if I take anything which is greater than minus 4 but less than 4. For example, 0. Does 0 work? Does 0 give you output? So that the process of the function is whatever it gets, it squares it, subtracts 16 from that, and takes the square root of that. So it will give you a 0 root over of 0 square minus 16, and that is root over of minus 16, which is not a real number. So 0 does not give you any output. You can check with other numbers between minus 4 and 4, and none of them will work. Okay. Does 4 and minus 4 work? That is like you should comment here that 4 and minus 4 is working. Do they give you any sort of image? So just try to understand that and just comment down below. Okay. Now we look into another example. Yes. So that is the example here. Yeah. Let's go back to the example here. So that is the example here. We see a denominator. So therefore, the denominator must not be equal to 0. That was another technique that we have seen. This is not equal to 0. And I'm not going to work it out. You can very easily understand that factorizing this will become x minus 2 and x minus 3, which should not be equal to 0. So product of two things not equal to 0 means both of this should not be equal to 0. That means x should not be minus 2 or minus 3. None of the values are can be considered. Okay. So x, what can be x then? X can be any real number. X can be any real number except these two values, minus 2 and minus 3. So what is our domain then? Our domain is all possible real number except minus 2 and minus 3. That's fine. That was the second technique. Now we see another function where we have the denominator as well as a square root. Okay. So in this case, x square minus 9 should not be equal to 0, as well as x square minus 9 is greater than 0. Greater equal to 0. So if we combine these two conditions, here it says it can be greater than 0 or equal to 0. Here it says it's not equal to 0. So we should not consider equal to. So what we should consider, x square minus 9 is greater than 0. And by the same condition as we have seen earlier, we get x square is greater than 9. So x will belong to, which is 9 is 3 square. So x square belongs to minus infinity to minus 3 union 3 to infinity. And notice that I have given the open intervals here because there was no equal to sign. Okay. So these are the main techniques of finding out domain. Now, as a bonus, you will have a worksheet attached to this video. Maybe like this video, whenever this video is going to upload it, after some time, you will get a worksheet attached to this video. You can fill out this worksheet. There will be some homework problems for you so that you can work it out. And if you have any doubt, you can send me. I'll be posting there'll be a section to post your doubt there. You can give your doubt. I'll definitely try to contact you and solve your doubt personally. One more thing to announce, if you want to take live classes with us with the unreal numbers, then you can feel free to contact the number that is given in the description. Okay. So hope you like this video. We'll be coming up with more and more videos. Actually, we are going to cover the whole syllabus of class 11 and 12, and class 12 videos are coming really soon. Okay. So we are going to cover up whole syllabus of class 11 and 12, and then for class 9 and 10 also, I'll be bringing videos. Okay. Here. So that will be all for this video. We'll meet very soon with a new fresh topic. And our topic for next week is going to be finding the range of a relation, and also we'll see the sketching techniques of functions. Thank you for watching.